So what we've talked about so far in a previous series, we've talked about relative humidity and what it is in a house and really how it affects your health in the house through air currents. And we said that air currents are convective currents. So which kind of segues into what I'd like to talk about right now, which is our fans that are within the house. Our vent fans in the house, not our ceiling fans, but our vent fans. And what's the purpose of a vent fan? As an energy auditor in the state of Washington, one thing that we are tasked with doing a lot of times if we do an energy audit on a house is to identify the size of the fan. And so what we mean by the size of the fan is actually how many CFM, cubic feet per minute, does the fan move, and how noisy is the fan. So there's a laboratory in California called Lawrence Berkeley Laboratories, and it's an EPA lab. And it's important to understand this, that these tests that are done on our mechanical systems within a house are also regulated types of tests. So the EPA lab tests basically everything in the energy world. So as an energy auditor, it's very important for me to understand these things to basically make a determination. Is the fan that's in your house, is that a good fan? Or should you upgrade that fan basically to get rid of that fan? So what that study determined through Lawrence Berkeley Laboratories is it determined two things that make up a good fan. The first thing is that a fan in today's code needs to be a minimum of 60 CFM. In other words, 60 cubic feet per minute, how much it will draw. Although that study did not predicate what the noise level is for the fan. So as you go lower on the zone level, now we can get fans down to like a 0.6 in their zone, which means they're whisper quiet. So the old days of not wanting to turn the fan on because it was too noisy, or turning it on because it did make a lot of noise and you didn't want to hear who was in the bathroom, those kind of days are over. So what the study told us about the fans, to measure whether a fan is 60 or 65 CFM or greater, boiled down to two things from this study. Now, as an energy auditor, you would think I'd have to get out a bunch of test equipment and all that type of stuff. No. What the study showed us was two things. If a fan doesn't hold 2 pieces of 2-ply toilet paper, now non-brand specific, but if it doesn't hold 2 pieces of 2-ply toilet paper, it's basically no more than a noisemaker. So what you want to do is get rid of that fan. So that was one of the biggest things that came out of that study. And then it also measured our noise level. So we want to try to get fans now to like a 0.6 zone. So when we do an inspection on a house, and we're talking about how to remediate the bad air or the relative humidity or the mold. So we're very, very familiar with mold. People are familiar with mold, or they see it in their houses and they don't know how to get rid of it. So the first thing that we want to do is we want to address the fans and the ventilation within a house. I'm an advocate when I talk to people of actually increasing the size of your fan anywhere from a minimum of 80 CFM, actually even up to 120 or 125 CFM, and you get a fan that's of 0.6 zone or less, if they make them now, to basically so you don't hear the fan come on. It's been shown through also other studies that we've done is that a fan, even of a capacity of 65 CFM or greater, it takes a minimum of about 2 hours to actually get the airflow from the house to the fan so you start expelling the air. So leaving a fan on only for 20 or 30 minutes or even an hour, a lot of these timers that you see are only set for an hour. That really is not getting anything but what's in the immediate area of the fan. So it's not really pulling the air from other parts of the house. When we talk about the fans and pulling the air from other parts of the house, what we have to remember is not so much what the square footage is with your house. You may have a 2,000 square foot home, but the volume of air that's within your house, the length times the width times the height. A lot of times we deal with rooms that have a tremendous amount of volume of air in the house. So what we're trying to do is move a certain amount of volume of air in the house. So the stronger the fan is, the more enabled that it is to move a larger volume of air through the house. I encourage people during their heaviest times of usage. So let's say in the morning, you get up, you cook, you clean, whatever, maybe you throw a little laundry in. Those are the times in which to use your fan. So I tell people to turn the fan on or put it on a 24-hour timer, buy or upgrade to a timer that you can actually set for 24 hours. So once it's set, you never have to worry about it again. So therefore, if you have a fan that you can set for, let's say, 3 to 4 hours in the morning, a couple 2 to 3 hours in the afternoon, and then let's say 4 to 5 hours at night. Why that much at night? Simple reason is most of the family is home during that time. That's when your heaviest usage is. Everybody's taking showers, everybody's throwing laundry in, getting ready for the next day. So to have 4 or 5 hours a night, actually think to ventilate my home 12 hours a day Yeah, I really encourage that. You cannot, in my opinion, over ventilate a house. You can most certainly under ventilate, and you suffer from the health related aspects that mold and relative humidity create within your house.